Video problem number 43, mass calculations for reactions. We're staying in this stoichiometry topic here, and these are going to be grams to grams. Okay, let's check it out. How many grams of C6H12O6 will form if 17.91 grams of carbon dioxide reacts completely? So with these, what I like to do, I still use the roadmap, and I just go by a simple rule. So this says how many grams of C6H12O6. So I'm going to write a line with a G. Anywhere I write a line with a G, I write a line with a moles directly underneath it. Okay? We have 17.91 grams of carbon dioxide, so that's a line with a G. Anytime I write a line with a G, directly underneath it, line with a moles. So I'm going to go from grams to moles, which just uses molar mass, moles to moles, which uses the mole ratio, and then moles to grams, which again uses molar mass. Okay, so let's go ahead and get started. I've got 17.91 grams of CO2. I'm going to convert that to moles of CO2. So I'm going to put grams on bottom so it cancels out. Moles on top. Moles over grams or grams over moles. We're talking about molar mass of whatever's in front of it. So I need to get the molar mass of CO2. So let's jot that down here. Carbon is 12.01. Got the two oxygens, each one is 32, so that's going to be 44.01. Okay, that's how many grams are in 1 mole of carbon dioxide. So 1 mole, 44.01 grams, okay, and that's going to be some value. So we can go ahead and get that value now, or we can continue on with our dimensional analysis. I'm going to go ahead and get a value right now. So that gives me 0.407 moles of, in this case, CO2. Grams cancel out. There we go. 0.407. And of course, I'm just going to keep that number in my calculator. I don't want to round too early. Okay? So I'm going to go from moles to moles. So I'm going to get rid of CO2, and I'm going to pick up C6H12O6. Notice I don't get rid of the word moles. So CO2 cancels out. I end up with moles of C6H12O6. There is 1 C6H12O6 for every 6 CO2s. So basically I'm going to take my number and divide by 6. And I get a value of 0.0678, and that's going to be moles of C6H12O6. So that gets me right here. And now I'm going to go from moles to grams. So I got moles. I want to get rid of moles. I want to pick up grams, grams over moles, moles over grams, talking about molar mass. So let's go ahead and calculate the molar mass of that big compound there. So it's C6H12O6, okay. 6 times carbon, which is going to be what? 72.06, right? 12.01 times 6. 12 times hydrogen, so that's 12 times 1.008, which is 12.096. And then I've got 6 times oxygen, which is 6 times 16. So that's, is that 96? Yeah, that's right. All right, add all those up. Let's see, I got 96 plus 12.096 plus 72.06. It's around 180. So this ends up being 180.156 grams per mole. So 180.156 goes there, that's grams in 1 mole. So I'm going to take that 0.0678, go back and find that number, and I'm going to multiply by 180.156. And I get a value of 12, let's go to 3 sig figs here, 12.2 grams of C6H12O6. Sorry, I had to get off the page there. I know you can't do that. Okay, let's do the next one. It's going to be the exact same idea. Okay? Determine the mass of aluminum nitrate. Alright, so which one is aluminum nitrate? Alright, so it's this one. That's grams. Anytime I write a line with G, I write a line with moles. If 18 grams of barium nitrate, so anytime I write a line with a G, I write a line with moles, reacts with an excess amount of aluminum sulfate. In other words, I have plenty of that to use up all of my barium nitrate. So I'm going to do the exact same path here. I'm going to take 18 grams of barium nitrate, BaNO3, 2. First I'm going to convert to moles. right? So I get rid of grams, moles on top, grams over moles, moles over grams. We're talking about molar mass. Okay, so let's get the molar mass of barium nitrate. Right. Barium, what you do to a dead guy, that weighs, how come I can't find it? There, 137.33 grams per mole. Okay, I've got 2 nitrogens. Each one weighs 14.01. And then I've got 6 oxygens again, which is 96. So when I add all that up, let's see what I get. 96 plus 28.02 plus 137.33, and I get a value of 261.35. That's how many grams per mole. Okay? So 1 mole, 261.35 grams. So I want to take 18 and divide it by that number, and I get a value of 0.0689, and that's going to be moles of barium nitrate. Right? So 0.0689, that's a 0. So that's going grams to moles. Now I'm going to go from moles to moles. So let's do that down here, 0.0689. That's moles of barium nitrate. All right. Let's see, what am I doing? I'm going from moles to moles. So I want to get rid of barium nitrate. I want to pick up aluminum nitrate. There are 2 aluminum nitrates for every 3 barium nitrates, and I get that just from the mole ratio right there. All right. So let's see, I'm going to take that value times 2, divided by 3, and I get 0.0459, and that is moles of aluminum nitrate now. So that gets me right here. And now I'm going to go from moles to grams. So let's bring that number on down. That's moles of aluminum nitrate. Ooh, where'd I go? Sorry about that. Grams on top, moles on bottom, grams over moles or moles over grams, talking about molar mass. And this is going to be aluminum nitrate. So let's go ahead and get that over here. Here's the molar mass of aluminum nitrate, AlNO33. So I've got 1 aluminum, which is 26.98. I've got 3 nitrogens, so that's 3 times 14.01, which is 42.03, and then 9 times oxygen this time. So that's 9 times 16. So I get a value of 144. Okay, I'm going to add that to 42.03 and add that to 26.98. And I get a value of 213.01 grams per mole. So let's go ahead and put that down here. 213.01 grams per 1 mole. That times that real small number, 0.0459, and I get a value of 9.8 grams, moles cancel out, of aluminum nitrate. I only want 2 significant figures here, so there you go.